This is geometry. This is our worksheet for review for the CPCTC. Corresponding parts of congruent triangles are congruent. This is after the first lesson. Name the 5 ways to prove triangles congruent. We have side, 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 angle, side, angle, angle, side, angle, side, angle, and then RHL. Remember, the S's stand for side, A stand for angles, R stands for right triangles, H hypotenuse, and leg. Here we're going to look to match up the different ways you prove triangles congruent with the different situations. Here notice we have 2 A's and the S, which is called the non-included side. It's not in between the A's. So if it's not in between the A's, it would go here with angle, angle, side. Here we have all 3 sides matched. So of course that would match with SSS. Here we have right angles, which can be considered congruent or they can be considered right triangles. We've got to see which way helps us most. Then we have a pair of sides, which these would be called the legs. And this reflexive side tells us that we have a second side the same. But notice the order. It's 2 S's with an angle not in between those S's. SSA is not a way we can prove triangles congruent. Neither is angle, angle, angle. So the only option that's going to work here is RHL, a right triangle, a hypotenuse, and a leg. Here, if M is the midpoint, then we have 2 sides that are going to be the same. 2 S's with the A that's in between. And then 2 A's with the S that's in between. So that's our matching. Angle, angle, angle doesn't make triangles congruent, and neither does SSA. What would be the third congruence necessary to prove the triangle is congruent? And then write a congruent statement. Here we have 2 sides that match, another 2 sides that match, and of course, if we're going to prove it by SSS, we would need a third side that matches. So the part that we don't have is that DB would be congruent to BD. We use the letters in opposite order because in the top triangle, if we would say D to B, we would be going from the side containing the 1 tick mark to the 2 tick mark. In the other triangle, we would want to go in that same direction from the 1 tick mark over to the 2 tick mark, which would be B to D. The congruent statement is triangle. Now there's 6 correct ways to name this first triangle. ABD would be a pretty common way to do that. Is congruent to triangle. The second one has to match what I did here. The A was in between the sides, so we got to start with C. B was down the 2 sticker, so I'm going to start with D. And then we finished off with D, which from the B was down the middle, so I'm going to finish with B. So that's showing me that AB, first 2 letters, corresponds with CD, the first 2 letters. The last 2 letters, BD, matches D to B. And then the first and last matches the first and last. If we're going to prove it by angle, angle, side, we need to come up with another pair of angles that must match in that correct order. Notice that in this picture also, they have sides that are labeled parallel. So if they're parallel, then we have these alternate interior angles that makes this zigzag pattern. and we're going to be able to prove the triangle's congruent by angle, angle, side. Two A's with the S that's not in between them. Do recall that parallel sides do not have to be congruent, so that doesn't count as sides congruent. So what we needed to know was angle MNP. The vertex has to be the N, but you got to use 3 letters. Would have to be congruent to angle OPN. And the triangles, we could use the same letters, MNP, 1 tick mark, 2 tick marks, and the one that's not labeled, to the 1 tick mark, 2 tick marks, and the one not labeled. We're going to use SSA. This example doesn't have a good reason why these have to be congruent, except it's just asking us for what would be necessary to prove them. Well, we would need to know the A, the angle in between the 2 S's. So we would need to know that angle G was congruent to angle J. The other 2 problems, we could verify why those angles were congruent. Here we can't verify that. They're not vertical. There's no reason that they're congruent, but that would be the necessary part that we would need. So triangle GHK would be congruent to triangle JKH. Remember, there are 6 correct ways to name the first triangle, so there's 6 correct ways to write a congruent statement, but you only have to write 1. We're going to show it by angle, side, angle. Here's our parallel lines. Again, we have the zigzag. So we would have a pair of angles the same. Then here we would have a different zigzag. So we would have another pair of alternate interior angles. And then the part that we're not sure about, but now we can see it, would be the reflexive property. So we would need to know that angle STR was congruent to angle VRT. We would also need to know that angle SRT was congruent to angle VTR. And that RT was congruent to TR. And when we did that, we could say that triangle STR is congruent to triangle VRT. Here, if we're going to use RHL, then we're going to have triangles that are congruent. Well, let me say that again. If we're going to use RHL, we have to have triangles that are right triangles. They must be right. That's what the R stands for. Not necessarily right angles. Of course, right triangles have right angles. But the R specifically stands for right triangle. So if you were doing a proof, you would have to state that you have right angles, then you have right triangles. It is not necessary to say that the angles are congruent. We also have the reflexive side, which is our H for a hypotenuse. So we would need to know that CG is congruent to CG. And we could prove the triangle is congruent by FCG is congruent to triangle TCG. Okay, now we're going to think about how triangles would be congruent. Then notice what 3 sides or pairs you would use. How would we prove the triangle is congruent? Once we prove triangles congruent, there are other parts that now have to be. Once the triangles are congruent, all the corresponding parts are congruent. So we're going to list all three parts that have to also be congruent. And that's called CPCTC. In class, we like to use if two triangles congruent, then corresponding parts congruent. The if-then statement is how we like to write our reasons in our proofs. CPCTC, corresponding parts of congruent triangles are congruent, is a shortcut method that the book will use. Many of the teachers will also discuss CPCTC. I do prefer it to be written as if-then, but if you use CPCTC and you use it correctly, of course, that is acceptable. So we could prove this triangle congruent, noticing that DB would have to be congruent to BD. So the triangles are congruent by triangle ABD would be congruent to triangle CDB by SSS. Now, what are the three additional parts? I know the one pair of sides are the same. The other pair of sides are the same. This new side is the same. That would be the reflexive. It's almost like writing a proof. What are the three new sides, or three new parts? These would be angles. We could say that angle A is congruent to angle C. We could say that angle ABD, this one right here with B the vertex, is congruent to triangle or angle CDB. And also we would have angle ADB congruent to angle CBD. And our reasoning for that would be CPCTC, or if two triangles are congruent, which we've already shown, then the corresponding parts. The A goes with the C, the B angle goes with the D angle, and the D angle goes with the B angle. For this figure, we've already worked with a parallel line, so we know that this angle goes with that one. This one would have to go with that one. And our third bit of information would have to be here in the center. So we're going to prove the triangle's congruent. Prove triangle STR congruent with triangle VRT. And we would use angle side to do that, kind of like writing a proof. The new parts that we haven't talked about yet, angle S would have to be congruent to angle V. Because the triangles are congruent, I know this is possible. I wouldn't have known it beforehand. Because the triangles are congruent, I know these angles are congruent. I also know that SR, first and last letter, has to match with VT. And also that ST, segment ST, first two letters have to match with the first two letters. And that reasoning, if you were writing a proof, that reasoning would be if two triangles are congruent, which they are, then the corresponding parts are congruent. Here we have two right angles. I'll have to try to figure out if I'm going to use congruent angles or if I'm going to use right triangles. The other information they give us are two sides plus our reflexive side. So because the A is not in between the two sides, side-side angle doesn't work. It's not a way to prove triangles congruent. So I would have to use R for right triangle, H for hypotenuse, and L for leg. So triangle FCG is congruent to triangle TCG because of RHL. And because those triangles are congruent, I now know that FC is congruent to TC. First two letters and first two letters, they would have to be congruent. Angle FCG, notice I'm using 3 letters because at point C there's too many angles happening. TCG, and the third bit of information would be down with the other pair of angles. Angle TGC being congruent with angle FGC. For the same reason, if two triangles are congruent, which we already know, then the corresponding parts. What makes them corresponding? If you look at your congruent statement, you'll see the first 2 letters are supposed to be corresponding with the first 2 letters, the last 2 with the last 2, the first and last with the first and last. Those would be your segments. The angles are angle F and angle T. What would make up angle C and angle C, FCG and TCG. And then what would make up angle G, FGC, and what would make up G on this side, TGC. On the back side, let's finish up our proof. We know that WX is a side of the triangle with XY. That's part of our given. We also know that Z is the midpoint. So Z is a midpoint doesn't mean anything specifically to mark on your graph, our picture. But it does lead us to something else. And the other part that it leads us to is knowing that we have 2 congruent segments. So we'll have to say that specifically in our proof. That's all the information that comes from the given. Now we're going to need to look for another piece of information. Maybe it's the angles that are in between the 2 sides for side, angle, side. Or we know that we have a third side. And of course, we have the reflexive side. You don't ever want to miss that because it's so clear. So, statement 1 is that WX is congruent to YX, and that Z is the midpoint of WY. Both of those are from the given. Now there's nothing else for us to say about WX and YX, but this midpoint, I know something else must be said if there is a midpoint. Midpoint doesn't say it exactly. What needs to be said is that WZ is congruent to YZ. That hasn't been written here. It's not written in the given. That needs to be said. What allows us to give that statement? If midpoint, then 2 congruent segments. So far we have an S, and then we have another S that are congruent, 2 sides that are congruent. What's another piece of information our plan showed us that we would need to use? We use the reflexive property there in the middle. And notice this time we're going to use the letters in the same order for reflexive because we're coming down to the bigger of the angles. The triangles are folded, they're not twisted, they're folded of each other, a reflection. So they're going in the same direction. XZ of this triangle and XZ of the right triangle other triangle are congruent to each other. So we call that the reflexive property of congruence. POC, property of congruence. That's our third side. So now we're ready to say that triangle WXZ. Now there's 6 ways to name that triangle. You may name it any of the 6 ways you wish. But the second triangle has to be named in the correct order that corresponds with this one. W, so I'm going to start with Y, then X, then I finish with Z. And that was side, side, side congruence. Remember, there are 5 ways to prove triangles congruent. The only time you can use that is if it matches the triangle, and the correct method has to be displayed in your figure. Once the triangles are congruent, then I can talk about the corresponding parts that are congruent. The corresponding parts, notice that Y, X, Z, which is up here, and WXZ, which is over here, they are both the middle letter of both of these triangles in the congruent statement. So if 2 triangles congruent, then corresponding parts are congruent. Here we have A, B, and C, D. They're parallel, which we're supposed to think of something specific. As soon as you hear parallel, most every time in geometry class, you're supposed to think of the 4 types of angles: alternate interior, corresponding, consecutive interior, and alternate exterior. Those are your 4 type of angles that occur when lines are parallel. And those angles will either be congruent or supplementary, depending on the type. Well, if we're going to talk about AB being parallel to CD, and we have our transversal that goes in between, we have these 2 angles that are formed by the zigzag. So if parallel lines, remember the if part has to always be stated before, or at least in the picture, then alternate interior angles are congruent. It's important and required for you to name the type of angles that you're using. Don't just say, then angles are congruent. You got to say alternate interior angles. The other bit of given information that they're going to tell us here is that AB is also congruent to CD. It's parallel, and in this case, it's congruent. You can't assume that every time just because they're parallel. That was part of the given. Then we have a reflexive side. Reflexive property of congruence. So what do we do now? What's next in our proof? We're going to prove the triangle's congruent. So ABC is congruent to triangle DCB. What's our reasoning for that? There are 5 possible answers. There's only one correct response. So it would have to be side, angle, side. We have 2 S's with the A in between. Your last statement is always what you're trying to prove. And what is our reason? Why do those have to be congruent to each other? If two triangles congruent, that's what we have earlier, then what's happening right now? Then corresponding parts are congruent. Last one. This apparently is number 13. So, angle CAB. Where is angle CAB on your picture? Right there. Is congruent to angle DBA, which is right here. So notice what's happening. We're overlapping triangles. We're not talking about these two triangles on the outside that might have vertical angles. We're talking about the big triangles that are overlapping, so we don't have vertical angles with those. So let's redraw that and call it ABC. And then ABD. We know that this angle and this angle are congruent. We also know that angle C is congruent to angle D. We'll put 2 tick marks on those to show that they're different than the A and the B. With them separated, it's kind of difficult to tell. But what is our next piece of information that we can talk about? We currently have 2 A's. We need to come up with a third bit of information. And it's definitely not going to be another angle, because you can't prove triangles congruent by angle, angle, angle. It's going to be the reflexive property. You might see that in the original picture. You'd have to look at the letters carefully to notice that they have the same pair of letters. AB and AB. Both triangles have AB, so that segment, of course, has to be the same length. That would prove the triangle's congruent by 2 angles and a side, angle, angle, side. And then because they're congruent, I know that their parts are going to have to be congruent. So let's start out with our given. So we'll put all the given up front this time. You could separate it if you want. But because they're pretty much independent of each other, they don't lead to anything new, we could just throw them in the front. Next part we need to talk about is how AB was congruent to BA. When we said AB for the first triangle, that was from the big angle out to the little angle. So the other triangle, the big one to the small angle. That's why we switched the letters for this case. I've got an angle, and a side that are labeled here. So I have enough information to show the triangle's congruent. So B, A goes with the B. The B, which is the small angle, goes with the small angle over here, which is the A. And then the C is going to go with the 2 ticker down here at the bottom, which is D. And we prove the triangle's congruent by angle, angle, side, congruence. And then, after the triangles are congruent, we can talk about how their corresponding parts have to be congruent. So CBA is congruent to angle DAB if two triangles congruent, then corresponding parts are congruent. Remember, the shortcut to that would be to call it CPCTC. Corresponding parts of congruent triangles are congruent. That's not written in if-then form. This is your if-then form. I prefer that. Either way would be acceptable.